Also backed by popular demand is Professor Ashok Jhunjhunwala. He captivated the audience last December during Reunion Day. May I now request Professor Jhunjhunwala to weave his magic yet again.
Will you settle down? Those who want to leave can leave. We are quite used to students leaving. So I know you are no longer students, but those who want to stay. Many of you have heard of Research Park. I'm sure you are going to see the Research Park sometime during your stay here. It's about 5 years old. Basically, we brought in a very important new facet into the campus. We used to be students and faculty, and now we have brought in industry. So the industry, we have set up this industrial R&D, and they are with us. And they are starting to change all of us. They are starting to change themselves. They are changing the faculty, they are changing the students. All of us have started changing as a result of that. We are taking up more difficult challenges, something that we could have even only dreamt of. And in many areas, the faculty and the students are starting to sort of say, we'll change the world. Or at least to begin with, we'll change India. So what I'm going to present to you is something that some of us have been doing. I have been involved, Bhaskar Ramamurthy is involved, Professor Krishna Vasudevan, Professor Lakshmi Narasimha. The important thing is that some of us are not people who are specialists in power. Some of us, you who know us, know that we are a communication people. But we all live here, live in this country, and one of the most serious problem that we face, excuse me, somebody has to turn this on, and one of the most serious problem that we face is power. The power cuts, I'm sure there must have been power cuts when you were here. It has only grown. Most of you understand the problem of power. The power cuts in India range from 1 to 2 hours to almost 16 hours a day. And it will come as a shock to you that about 32% of our homes, 33% of our homes are not connected to the grid. That amounts to about 70 million, not small number. So some of us decided that we'll like to do something about it. And that's more or less brought Bhaskar, into this whole system. It is in this context what I am going to do is make a short presentation on what I believe is the next generation powering of Indian homes and capitalizing on 3 basic things. One is decentralized solar green energy, second is energy efficient DC appliances, and the third is smart load management. I think we have kind of combined these 3 things in a very unique manner to try to get something which I think can make a huge difference for the country. Let me start with, most of you have heard of solar panel. The solar panels that sits on a rooftop can certainly supply us power. I don't know how many of you understand that solar power gives us DC power. And what do? Our grid is AC power, so when we connect it to the grid, what we will do is that we will actually put it through a DC to AC converter, and we will synchronize it to the grid. The next thing that happens is that very often the solar power fluctuates. So because solar power fluctuates, we will almost invariably put a battery, but the battery only stores the DC power. So what we do is once again a AC to DC converter, and when we take the power out from the battery, we again put another DC to AC converter. I don't know how many of us realize that each of these AC to DC, DC to AC converter not only costs money, but loses power. The efficiency 15% for a normal medium cost system is high efficiency. So, basically what happens that almost 45% of the power that we generate through solar, the expensive solar system basically gets lost before it comes to the load. And this is something that we have been doing, the country has been promoting, all of us have been just using it left and right. This is something that we are quite used to. The problem gets worse when we start realizing what do we do with this power. In most homes, we actually, the first thing that we need is a light and a fan. This is the first thing that we need. Take a typical fan that we use at our home consumes about 72 watts. Those of you still remember a little bit of your electrical engineering, it is designed using an induction motor, AC induction motor. Fortunately, today you can design the same fan, exactly the same fan with a brushless DC, BLDC motor, brushless DC motor. If you do that, the power consumption goes down from 72 watts to 30 watts. Now, this is were the brushless DC fans not available? They were available even in 60s and 70s, but we didn't even probably learn about it. I don't remember, I was in IIT Kanpur, I didn't learn about it. Partly because it was just too expensive. But with the revolution that has taken place in power electronics integrated circuits, integrated circuits, and that took place in last decade. The ordinary integrated circuits, low power integrated circuits started in 80s, 70s and 80s, but the high power integrated circuit started somewhere in the decade of 2000 to 2010. And suddenly you can actually design a fan which is almost the same cost as that of a AC induction motor fan and consumes only 30 watts. What is more important that we don't normally always run the fan at the full speed. If we run it at the lowest speed, a AC fan still consumes about 60 watts, but a DC fan consumes only about 9 watts. So, first of all, I think the 2 points that I am making is for the load like fan is becoming a DC powered load, and it is far more efficient to use a DC powered load. Same thing is happening with lighting. A typical lighting that we use, lighting like this, is about 36 watts. A equivalent LED lighting will be about 15 watts. What is more important again, that LED lighting can be dimmed further and can consume less and less. It can consume as little as 4 watts. So, essentially if you see light and fan load due to energy efficiency is all going to move towards DC, and we could have directly taken DC and used it. Instead of that, we converted DC to AC, AC to DC, DC back to AC, and now we will bring it back to these appliances and convert AC to DC. This is not all. Take electronics. All electronics we know work only with DC. So, what we do? We use a power converter, adapter. I have a HP laptop, that converter, the loss is about 33%. My Nokia cell phone charger has a loss of about 50%. If I used it directly with DC, my loss could be very, very minimal, 5-10%. I may have to change voltage, I may have to have a DC-DC adapter, or ultimately some of these devices can come with the standard voltage whatever we are going to use, and then there is no losses at all. The television is the same thing. And not only this, if you look at even the future devices like refrigerators, air conditioners, washing machines, they are also starting to become DC. If we start using these, then we actually use, our load becomes less than 50%, probably 40%. And therefore, what we could have is a totally different system where solar remains on DC. For example, this is a kind of system that we have designed. The grid at home gets converted to DC, gets synchronized to it, and the battery remains at DC, and the load is then supplied a DC system. Something like that is between 2.5 to 3 times more efficient as compared to a normal situation. And this kind of system is what we actually designed. We started implementing first at homes within and offices within campus, and then outside, and we have just scaled that up. Now, this is one component, but there is another very, very important thing that we did, and this is a load management innovation. Basically, the situation was that, well, solar is all right, solar and battery will still work out to be expensive. Can I actually get power from the grid? Can I get a 24/7 power from the grid? And can I use load management to do that? Today, whenever there is a shortage of power, there is a blackout, the power is cut out in select localities. We actually defined a concept called brownout. Saying instead of blackout, can the substation near our home continue to feed a small amount of power, let us say 10% of the power on those lines. If it continues to feed that power, then maybe we can get at least that much power at home. Now, what can the 10% power do? I will come back to that. But how do you go about doing this? Well, what you actually do, at the home you get a AC line, but within the home you use a converter and you can put into two lines. One line is your normal AC line, where you can draw unlimited amount of power, whatever your you have kind of opted for, but the only thing is that will be cut out during brownout. Whenever there is a shortage of power, it will be cut out. The second will be supplying about 10% of the total power, but it will be supplied as a DC. We will put a AC to DC converter out here in this unit. This is a DC meter and this will be a DC power. This will be supplied 24/7. Why? Because there is no blackout now. We will have a brownout. When a brownout is there, this power is always available. So, this is always available, even though this can be cut out. A very simple kind of innovation, and we sort of said that can we actually do this without changing anything in the distribution system. And we actually figured out a mechanism by which a small change in the substation and an addition of a small unit at each home, and suddenly we can get two lines. One is a normal AC line, which of course is cut out whenever power fails or whenever there is a brownout, but the other line becomes a 24/7 power. Now, what happens? Once you get power, a line like this, a DC line, you start getting used to a DC line. And as you start getting used to a DC line, you will start using DC lights, DC fans, and suddenly you want more and more. For example, let us assume that only 100 watts is supplied to you. Now, one will say, what will 100 watt do? Normally you consume a kilowatt, let us take a lower middle class home, now you are supplying 100 watts. Well, 100 watts can actually go a long way. It can supply 3 LED tube lights, 2 fans, 1 cell phone, or it can actually supply 3 lights, 1 fan, 1 television, 1 cell phone. So, it is actually not bad. We totally get rid of blackout. But what if I want more? Well, if you want more, now you add solar, because the same unit allows you to just add solar. You add a solar panel and suddenly you can do more and more and more. For example, if you are ready to add a 500 watt solar panel, with or without a battery, it can support 5 fans, 8 lights, 2 televisions, multiple cell phone charger, tablet charger, which is more or less what we use. If I leave my air conditioning and other things out, this is what pretty much a upper middle class home uses. Now, the next question that kept on coming, so the 3 things we are combining together. First of all, no home will be under blackout. Every home will get a 24/7 power, a limited amount of power, but enough for lights, fans, and maybe even a television. Number 2, we start using energy efficient DC appliances, where the power consumption is less than 50%. And number 3, we start using solar more and more. Now, using this solar, what does it do? And to just give you a picture, we have 240 million homes in India. If we install on the average 500 watts, which is only takes 50 square feet on every home, it generates 190,000 gigawatt hour per year. This is the total domestic consumption of the country today. So, essentially a 500 watts is all that is really required if we can do that. If we can kind of enable and sort of create a situation by which we can just keep on adding this, it can make a huge difference. So, this is exactly what our innovation attempts to do, that UDC and a solar DC, which will ensure that no blackout occurs, create a consumer demand and investment for DC appliances, and making decentralized solar photovoltaic attractive for home. What will happen? Today there is a large gap between demand and supply. As I start using the energy efficient appliances, my demand goes down and the gap reduces. As I start using more and more solar appliances, my supply goes up and the demand goes down. So, this is a very interesting method of creating a market situation where the lower supply and demand gaps goes down, and then by conventional methods of generation you can more easily fulfill this. At the same time, providing 24/7 power on day one. This is what we have been able to do, and in last year and a half, 2 years since we have been working, we have actually installed a lot. We have of course installed at homes, offices and labs at IITM. You are most welcome to come and visit us, see this installation. These are all working, you won't even figure out that these are DC. Plus what we did is that government gave us some support. So, this uninterrupted DC power, minimum amount of 100 watts to every home, where sort of say 4 states, 300 to 500 homes at Chennai, Hyderabad, Trivandrum, Orissa. Chennai is in Madurantakam, an hour from here, we have turned it on. The system is working, and it has been only working for last 1 month or so, but there is a huge hunger of people. Certainly say that they do not have blackouts. They always have lights and fans at their homes, and they have started using it. Today, Ministry of Power say they will certainly like to scale it, but they would like a larger POC of 100,000 homes, and they are in process of creating that. And once something like this happens, we will be able to start rolling this out in a very large manner in the country. Then at the same time, take the off-grid homes. While finally the power grid must reach every home, but can we do something quickly? So, we at IIT Madras took up a program, this off-grid home where we just put solar, DC and a battery. We started installing that. We are installing 25 homes in Nilgiris, in 25 homes in Orissa, 25 homes in West Bengal. In Sri City, there is a island there where there is no power off grid, and in Telangana 25 homes each. We have taken each one of them, and by February we will have installed all of that. The January 1st week we are actually installing it in Nilgiris, and from there onwards we sort of say we will install ourselves 100,000 homes throughout the country, off grid homes. Take off grid home 100,000, and this will do. Some government support is available. Government has agreed to provide us 30% of the money. We are looking at 45% of this coming from CSR and donations and maybe state governments, and about 25% plus the maintenance will be charged to the customer, because we are really going to those areas where the income levels are very low, and we are sort of saying that is the reason they are off grid. We are going to actually do that. This is what we are trying to do. What I was trying to present is one example of the kind of things that have started to happen at IIT Madras. We take big problems. How do you solve the power problem of India? Of course, you can generate more. You can get more coal, burn more coal. That is certainly possible. But our aim is, can we get 50% of our total power from solar by 2030? I think this will be a very important step. If we go in that direction, we would have probably created 20% of the power coming from solar. We would be probably the most green country by using energy efficient DC appliances which consume half the power of a normal appliance. We are again becoming very green, but what is most important that we are providing 24/7 power. I think this is something we are ready to take off. Similar kind of things is happening in the area of housing. Is there a presentation on this housing? Well, there is some very interesting work going on in housing, where we have come with IIT Madras faculty, Devdas Menon and group have come up with, Meher Prasad have come up with a very interesting way of actually building houses at half the cost, half the manpower required, and building low cost and yet structurally as good as any other homes. And this is something that we are starting to figure out how to scale. Same time we are trying to take up the water and sanitation problem and say, can technology make a difference there? So we have started looking at how technology can make a difference and take it all the way to commercialization and make an impact in the nation. This is something that we have started doing at IIT Madras, still a beginning. Over the next 10 years, I hope we will transform IIT, will transform the country, and we will on some of the areas become leaders of the in the world. The only problem that we face in doing this power is that has it been done anywhere else? Should we not wait till somebody else does it? And for once we are sort of saying no, we will lead this. Yes, this is a total new concept of load management. The smart grid management has been talked about. This is our way of doing smart grid management. Let us take lead rather than follow, and that's what we are trying to do. Thank you. Quickly answer one or two questions. UDC being connected, that's what our primary objective is, to get it in every home, a UDC, and let the customer then start buying DC appliances, and the customer put in solar panel as and when they want to expand. So in scale, this will cost us about 1200 rupees at each home plus a 500 rupees at the substation. So our total cost will be about 1700 rupees per home. This is the cost to actually do this second DC line at each home. After that, of course, customer will buy their lights and fans, gradually change over to DC lights and fans, and as they exhaust the power, they can put solar. For off-grid homes, because we are actually going to areas where there is no grid, we are installing solar panel, we are installing batteries, and we are installing lights and fans. These are first time the cost is around 25,000 rupees for one home to provide them one fan, one light, one cell phone charger, and a second light. That's what we are trying to do. 30% government has agreed to give, the paperwork is going on, and we are looking at 45% support from alumni, industry, donations, CSR. I'm sure we will be able to raise. I think we will take up a target of 100,000 homes and show 100,000 is not a small amount. Things like this have never been done in the country or in the world. If we can do 100,000 homes, I think the whole thrust will start, and then we will be able to make a difference. A equivalent system, if you design today conventional system, cost about 65,000-70,000 rupees. That's what the current system is. Out of which 25,000, about 5,000-6,000 rupees, 3,000-4,000 rupees is taxes, and 3,000-4,000 rupees is we are reaching those inaccessible areas. In fact, in the Nilgiri, the areas that we are going to do, it's about a kilometer and a half from the road. So we have to carry all these solar panels and all that batteries and things like that. Yes.
So is this commercially available?
Well, systems are starting to get deployed. UDC is, of course, has to be done by the power company. Cannot be. The systems are being made by companies. We have tied up with 8 different companies making different things. For example, 2 companies are making fans for us, TVS Lucas and Crompton Greaves. There are a couple of companies which are making lights for us. There are companies which are making all these systems. But the UDC has to be done by the grid, by the person who controls grid, the power company. The solar DC home is available, people can install. But I will sort of say wait for 3-4 more months. Our first few systems are now done. We would probably have done about a few 1,000 systems or so ourselves, and then I think it can actually be done. Many of us have installed it at our homes and all that. Yes, sir.
Other than LED lighting being more efficient lumen wise per watt, why do you say that a DC fan consumes less power than an AC fan?
Okay, I think we need to. I saw Krishna Vasudevan out here. He should be able to explain better. I think he has disappeared. There he is. Sometime a BLDC, brushless DC motor, a small size motor, consumes 40% of power of an equivalent AC induction motor. Now that's a property of this. The problem was designing of this brushless DC motor was complex. The electronics required used to be very, very expensive. And that's where the power electronics revolution has made a difference. The power electronics integrated circuits today, single chip can pretty much do something like this, and the cost has also tumbled. and as a result something like this is happening. There are other motors that are coming, SR motor. I'll say power electronics is becoming one of the hottest field. A lot of very interesting things will happen. The kind of changes that took place in 80s and 90s due to integrated circuits in low power electronics will start happening in high power electronics now, and BLDC fan is one example. I'll give you another example which is more familiar. If you remember, your cell phone charger 10 years back used to be a big hefty transformer heavy thing, and suddenly now your cell phone charger is practically very, very small, tiny, weighs practically nothing. The difference is there is no transformer there, there is basically a power electronics, a switching circuits, high power integrated circuits have started coming in. Yes, sir. Pardon? Yeah. So actually, the other thing that we are doing is on campus and in the research park, we are sort of saying we can generate most of our power through solar. In fact, all of our power can be generated through solar. And step by step, we are starting to install. We have installed 1 megawatt already at IIT Madras, 300 kilowatt at research park, and we are going to expand that. We will ultimately be in a situation where almost all the power we will be able to generate ourselves. Now, what is the trick? I mean, it's a conventional solar power system. We are of course using AC, but we will also start using solar power DC. For example, at my office and some of the labs, we are putting solar power DC. That significantly reduces the power consumption. But we have done something else. Rooftop space in the country is an expensive thing. People use it for various other purposes, whether to dry clothes or to hang around or do something. And if you go and start putting solar panels on the rooftop, most people do not like that. What we did in ESB, if you go and see, and now not just ESB, MSB, BSB, is actually raised and made it a little raised roof. Now, once you make a raised roof, very interesting things happen. You get a shaded area with all sides open so that you get wind. First thing is the space is still utilizable. In fact, it could be a very good. In fact, I've been encouraging my head of HOD to set up a good tea shop there. That will be a very good interactive place. Very nice air comes after 2 p.m. It's really very, very nice. Number two, what has happened is that by just doing something like this, we have essentially created a shade on the top floor. As a result, the AC load on the top floor, all the labs that we're using, that has gone down by almost half. And with fans blowing, air blowing, and having no direct sun has made a huge difference. What I'm trying to very simple innovation, thinking through how things has to be done differently. We learn from whatever else has happened, utilize it at your own place, in your own manner. I think this is something that we have started doing. We are doing number of other things, load management, load control as another important thing that we are trying to do. Solar power? No, it just absorbs. Yes.
Yes, sir. What is the openness of these power distribution companies with regard to the?
Well, 4 companies we have been able to convince, and they have participated with us in trials. I think as I told you, the only reservation has come from people, but it has not been done anywhere else in the world.
Yeah, I agree.
I think that is a big reservation. And we are trying to make a 48 volt DC. Now, the whole world is going to have that. Let me tell you, DC, if those of you have been hearing, IEEE has now standardization forum, etc. Except that time frame is 10 to 20 years. For us, we should do it today. Why should we not lead it? 48 volt DC standard we are starting to use. Of course, that is used quite a bit in telecom. It is used in like power over Ethernet, but we are trying to standardize it. As of now, there are a lot of bodies which are trying to oppose it.
Yeah, that's what
there are a lot of bodies, I'll say a lot of even NGOs, I'm surprised, foreign funded NGO, which are opposing it. I have no understanding why they will oppose something like this. Even some of the corporates are opposing it simply because they haven't started this. But they will turn around. It is up to us to go and sometime beg, sometime use our professor's hat or do whatever to sort of push them. And top management, wherever we have gone to any industry, top management has always supported us. Engineering has been a little bit more tentative, and we are hoping to get to that. But I think it's a very major thing, bigger than bigger than what we did in WLL, wireless and local loop, where we sort of say main telephony will be provided by wireless. I think it is bigger than that. That time also we had a lot of opposition, a lot of problems. This is bigger. All right? Yes, sir. I can't hear you.
Implementation of this directly to the wireless networks today, kind of seamless, because that's running on 48 already.
Yeah, so sure. I mean, in fact, many of the things we are just directly putting 48 volt DC, and all the network and everything we are just connecting to that.
Excuse me.
Yes, sir.
Two questions.
Yeah.
Okay, one, vision-wise, it looks very interesting, and you said POC is already working, and looks like the tagline is Roshni Bharat.
Pardon?
Just like Swachh Bharat, it looks like a Roshni Bharat. Having said that, if you go to the village like Maduranthagam, right, where you've done with 100 homes or whatever it is, are they stable? And what are the risks you've gone through?
Well,
and second thing is, when it's a solar panel, how often you need to replace it to get to the same level?
So solar panel typically lasts for about 25 years. There is enough studies, enough this thing for solar. We have not installed solar panel at Maduranthagam at all. We have just done a UDC. They are starting to install DC appliances. As they run out of the limited power that we give during brownout, they will start installing solar. This has been on for almost a month and a half. The DC part, solar DC, the DC part has been on for almost 4 or 5 months, apart from some initial teething problem that my fan should be here, not here. I think there has been no major problem. We have also done a few other things. For example, we have used a remote for now turning on, turning off our lights and fans, and they used to drop their remote and used to break. So those kind of questions, but minor ones.
Yeah, the second question is, since you said you have an interesting way of building houses low cost, why can't we see a model home with everything built in?
It is there, GFRG. Please walk in, opposite Taramani house. It was built in 32 days.
Okay.
On
and
campus. Not us, Devdas Menon and Meher Prasad. Bhaskar has played a major role in that. I think sometime just go and visit that. You won't even know. The important thing is structurally as good as any other home.
So at the broad level, what's the comparative cost of a normal home
About
building?
half. About half.
Okay, we'll certainly visit.
And
that.
up to 8 stories can be done. Up to 8 stories it can be done. Structurally it has been found to be as good for that.
Thanks.
Yes, one person, yes. Last, huh?
These new technologies that you talked about, can they be applied at these new campuses that's coming up in IITs itself?
Oh, sure. We will put
any
all
movement?
these
Any
things.
strong movement?
In fact, in the new girls' hostel, we have a top floor completely with DC. Unfortunately, the boys' hostel, the new boys' hostel, before we did it, somebody actually went and purchased the old fans, so we couldn't do it. But I think all our future construction will have this.
I think the new IITs are perfect.
Well,
examples where-
new IITs are another organization, so we have to go and talk to them and all that. But at least even our own expansion will be all done. But I think much more than that. I think we will catch the national attention much faster than that. Okay? I think with that I will stop. Thank you very much.
Thank you, Professor Jhunjhunwala, for that amazing presentation.